Hello everyone, how are you all guys? I hope you all are fine and doing well. This is your Pankaj Mishra sir. Welcome back to my channel GATE CSE tips दोस्तों। तो इस चैनल पे मैं एक सीरीज स्टार्ट करने जा रहा हूँ, इसरो की PYQ सीरीज स्टार्ट करने जा रहा हूँ, जहाँ पर मैं आपको मैक्सिमम सब्जेक्ट्स के इसरो के PYQ सॉल्व कराऊंगा, जिससे आपकी प्रैक्टिस हो जाएगी। ठीक है दोस्तों, जितने भी सब्जेक्ट्स में डील करता हूँ मैक्सिमम सब्जेक्ट्स के मैं आपको क्वेश्चंस PYQs कराने की कोशिश करूंगा इसरो के दोस्तों। तो आपको क्या करना है, जिन्होंने अभी तक इस चैनल को सब्सक्राइब नहीं किया है, सब्सक्राइब करके बेल आइकन को प्रेस कर लेना है ऐसे ही इंफॉर्मेटिव वीडियोस के लिए दोस्तों। और अपने फ्रेंड्स को भी शेयर करना है इस चैनल को, इस वीडियो को, जो इसरो की प्रिपरेशन कर रहे हैं, जो इसरो का एग्जाम देने जा रहे हैं दोस्तों। क्योंकि मैं चाहता हूं कि मैक्सिमम लोग जो है इस सीरीज से बेनिफिटेड हो पाए, इस चैनल से बेनिफिटेड हो पाए। अगर आप गेट की प्रिपरेशन भी कर रहे हैं तो यहाँ पर आपको फुल गेट का कंटेंट मिलेगा दोस्तों। तो चलो स्टार्ट करते हैं अपना सेशन, इस सीरीज को स्टार्ट करते हैं। यहाँ पर हम लोग डिस्क्रीट मैथमेटिक्स के कुछ क्वेश्चन सॉल्व करेंगे, इसरो के PYQ सॉल्व करेंगे। सबसे पहला क्वेश्चन आपकी स्क्रीन पर आपको दिखाई दे रहा होगा। सबसे पहला क्वेश्चन आपकी स्क्रीन पर ये वाला है, जो 2017 में पूछा गया है। Which one of the following Boolean expression is not a tautology? So discrete mathematics में we have three terms. Okay, like first one is tautology. How you will check the given Boolean expression representing tautology? Okay, first is what tautology. Second is what contradiction. I will give you okay all the concept, and third one is what contingency. Okay, so these three terms we have in the discrete mathematics. Okay, so how you can check the given Boolean expression is representing what tautology? Okay, if the last column of the Boolean expression contains all the entries are true, अगर Boolean expression के last column में सारी entries true हैं, तो वो tautology को represent करेगा। Boolean expression के last column में सारी entries अगर false हैं, तो contradiction को represent करेगा। और अगर मिक्स एंट्रीज हैं Boolean एक्सप्रेशन के लास्ट कॉलम में, लाइक ट्रू एंड फॉल्स, ओके, देन वो कॉन्टिजेंसी को रिप्रेजेंट करेगा। अंडरस्टैंड? सो दिस इज ओनली द थिंग ओके थ्रू विच वी कैन चेक। So what it is asking, which one of the following Boolean expression is not a tautology? Simple, we need to check through the option. Okay, only one option is true here. Okay, so we will go through the option only. So here we need, I am checking first option. So here we have three inputs A, B and C. So okay, so total how many entries we need to take here? 8. True, 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 then false, 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 false. Okay, then true, true, okay, false, false, true, true, okay, false, false, then true, false, true, false, like this, true, false, okay, true, false. Okay, so first we will calculate this A single implication B, means if then. So in single implication, if A is true and B is false, then only we will get what? False, otherwise we will get what? True. Okay, so A single implication B I am going to calculate here. So true, okay, whenever A is true and B is false, then we will get what? False, otherwise true. Okay, true, okay, then false, okay, then true, true, true and true. Okay, then B single implication C. Okay, so true, okay, false, true, true, okay, true, and here false, okay, and then true. Okay, then we need to do what? And. Okay, between these two we need to do what? And. So I am writing between these two and. Okay, so true, false, okay, false, false, true, false, true and true. Okay, then what we need to do? A single implication C. Okay, A single implication C. So true, okay, false, okay, true, false, fourth entry false, then all the remaining true, remaining four are true. Okay, then after we need to do with this result, and this result is what? Single implication. So final column is true, 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 true and true. So in the last column we are getting all the entries is what? True. Okay, with this Boolean expression. So this is representing what? Tautology. It is asking which Boolean expression is not representing tautology. So it is representing tautology, so option A is false. So we need to check option B. Okay, So in option B, we have also three inputs A, B, and C. So we will erase only this result. Okay. Okay. So here what we need to do, this is a double implication. In double implication, when A is true, okay, C is true, then we will get what true. When A is false, C is false, then we will get what true. Otherwise, in remaining cases, we will get result what false. Very simple. So A double implication, what we need to do, A double implication C, not B, C. Okay. This is if and only if. Okay. So here what we will get true, false, third one true, okay, false, okay, false, false, okay, and in this here we will get what true, not false, okay, because A and C both are false, okay. So here we will get what true, okay, here false, and here in the last true, okay. After this, we need to negate B. Okay, this column we need to negate. So false, false, true, true, false, false, true, true. Okay, when you have practiced and you are able to do very fast. Then A and C, we need to calculate here A and C. A and C means is what? True, false, okay, true, okay, false. Okay, then in remaining cases, okay, what false? False, 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 and false. Okay, so we need to do what? Single implication between these two. Okay, these two single implication, and B single implication A and C. So here we will get what? True. Okay, true, true, false. Okay, true, true, false, and false. After this, what we need to do? We need to do what? Single implication between this one and this one. Final result we will get. Okay. So here what? True, 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 and here true and false, we will get here what? False. So in the last column all the entries are not true. Okay, all the entries are not true. Okay, and it is a mixture of true and false. So this boolean expression representing what? Contingency. As I have told you in the last column, if you have mixed entries true and false, then boolean expression will represent what? Contingency. Okay, so here it is not representing tautology, it is representing what? Contingency. Okay, so this is the answer. Option B is the answer. Okay, only one option is correct in ISRO examination. Okay, MCQ questions are there, so option B is correct. No need to check C and D. If you want to check, then you can check. Okay, otherwise you answer B is correct here. I hope you understand. Okay, so option B is correct. I am going to solve the next question. This is your next question. Okay, and this question also asked in ISRO CS 2017. Okay, very good question. The proposition here, proposition is given as a, okay, tautology, contradiction, contingency, okay, absurdity. Okay, so I have told you, मैंने आपको बता दिया है कैसे आपको tautology check करना है, कैसे contradiction, कैसे contingency. Okay, so very simple. Here we have only P and Q to the truth table. So true, true, only 4 entries we need to take. False, false. Okay, true, false, true, false. Okay, this is single implication. P single implication. Q we need to calculate. Okay, true, true, false, false only, otherwise all the things remaining true. Okay, then after Q single implication P. Okay, true, okay, false, true, 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 false, false. Okay, false, 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 true. Okay, and we need to do what? And between these two column. Okay, so and is what? True. Okay, false. Okay, false, and true. So this and column of this boolean expression or proposition contains both the entries true and false. So not representing tautology, because when all the entries of the last column is true, then you can say that what? Representing tautology. When all the entries of the last column is false, then you can say that only representing contradiction. So here we have the mixed entries in the last column true and false. So contingency it is representing. So option C is correct. Okay, I hope you understand. Very simple question. I am going to solve the next question. This is your next question, and this question belongs to graph theory. Okay. In graph theory, mostly questions from the theorems or either from the statement. Okay. ISRO CS 2007 में पूछा गया आपका ये क्वेश्चन. A graph with n vertices and n minus 1 edges that is not a tree is. So आपको पता होगा अगर कोई ग्राफ है जिसमें n vertices हैं और n minus 1 edges हैं और अगर वो ट्री है तो वो अगर वो ट्री है ओके तो वो साइकिल को अलाउ नहीं करेगा और डिस्कनेक्टेड नहीं होगा. साइकिल को अलाउ नहीं करेगा और डिस्कनेक्टेड नहीं होगा. ठीक है, वो कनेक्टेड होगा. साइकिल को अलाउ नहीं करेगा और डिस्कनेक्टेड नहीं होगा. सो यहाँ पे कह रहा है ए ग्राफ विद n वर्टिसेस एंड n माइनस 1 एजेस दैट इज नॉट ए ट्री. ट्री नहीं है. सो ट्री अगर वो ट्री है तो डिस्कनेक्टेड नहीं होगा और साइकिल नहीं होगी. नॉट ए ट्री अगर ट्री नहीं है तो डेफिनेटली वो क्या होगा, डिस्कनेक्टेड होगा. क्या होगा, डिस्कनेक्टेड होगा. सो ऑप्शन बी इज करेक्ट है. ओके अगर ठीक है अगर वो ट्री नहीं है तो डिस्कनेक्टेड होगा. सो नो नीड टू गो. ओके no need to check option A, C and D or only disconnected. If a graph with n vertices and minus 1 edges then and it is not a tree then definitely it is disconnected. Option B is correct here. If a graph with, listen me carefully, if a graph with n vertices and n minus 1 edges is a tree then that graph is not disconnected. Okay and cycle is not there. Understand, neither disconnected or nor cycle. Okay if if a graph with n vertices and minus 1 edges is okay and it is a tree, it is not a tree then disconnected. I hope you understand, simply a statement. This is your next question. Okay also asked in ISRO CS 2007. If a graph requires k different colors for its proper coloring, direct statement, then the chromatic number of the graph is. So first you need to understand what is chromatic number. Okay what is chromatic number? Chromatic number is the smallest number of the colors through which we can color the vertices of the graph. Okay and no two vertices of the graph share the same color. Okay share the same color. Okay understand. So very simple, if a chromatic number is what, here we are required what, k different colors. Okay for its proper coloring. Okay to color the vertices of to color all the vertices of the graph. Okay so k here is what, chromatic number. Okay chromatic number, as I have told you, the minimum number of color requires okay to color the all the vertices of the graph. So that is called chromatic number. So here how many colors we required, k. So that's why my the chromatic number of the graph is what, my dear friends, k. Option B is correct. Option B is correct here. Okay chromatic number is what, the smallest number required to color a graph. Okay so here we required k different colors to color the graph, proper coloring of the graph. Okay so this k is representing here what, chromatic number. Next question is this, very simple question my dear friends. This is also asked in ISRO CS 2007 examination. Let x be the adjacency matrix of a graph G with no self loops. The entries along the principal diagonal of x are. Okay I am going to take a simple example like A, B, C, D. Okay like this. This is a graph. This is a graph. If we will form, and here we have like self loop. Here we have like self loop. Okay self loop and we are going to, I am going to make adjacency matrix for this. So x equal to what, A, B, C, D. Here we need to take A, B, C, D. Okay so A to A we have any okay self loop, yes we have self loop, so we need to put here what, 1. B to B we have any self loop, yes we need to put here 1. C to C we have any self loop, yes any edge, yes we need to put here 1. D to D we have any edge, yes we have a self loop, so we need to put here what, D. So of this इस एडजेसेंटी मैट्रिक्स में सारे के सारे डायगोनल एलिमेंट्स क्या है मेरे, 1 है. सारे के सारे डायगोनल एलिमेंट्स मेरे क्या है, 1 है. तो अगर 1 है तो सेल्फ लूप को रिप्रेजेंट कर रही है. ओके अगर एडजेसेंटी मैट्रिक्स में सारे मेरे डायगोनल एलिमेंट्स कोई भी है, सारे के सारे 1 है तो सेल्फ लूप्स है वहाँ पे. ठीक है यहाँ पे क्या कह रहा है, लेट एक्स बी द एडजेसेंटी मैट्रिक्स ऑफ ए ग्राफ विद नो सेल्फ लूप्स. इन दैट ग्राफ यू डोंट हैव एनी सेल्फ लूप. So all the diagonal entries will be what, there 0. Principal diagonal elements of x what will be what, 0. So when we have taken the self loops, okay, then all the diagonal all the diagonal elements are 1. Okay, so if any self loop in the graph G, then diagonal, all the diagonal element will not 0, okay, some 0 or some 1 if self loop is there. So here we have a graph in which we don't have any self loops. So it is asking in the adjacency matrix all the principal diagonal elements of X are what? 0. Okay, like this. Like this. We have a graph like this. Okay. We have a graph like this. So A to A we have any edge? No. So we will put here 0. B to B we have any edge? No. We will put 0. B to C we have any edge? No. 0. D to D we have any edge? No. 0. So all the diagonal elements of this adjacency matrix is what? 0. Then only we can say that the graph in which we don't have any self loop. So I hope you understand, very simple question. Okay, all zeros when all the entries of the when all the principal diagonal entries of adjacency matrix X is 0, then you can say that whatever graph you will get from the adjacency matrix in which you don't have any self loop. Okay, I hope you understand. Option A is correct here. Sorry guys. This is your next question, my dear friends. ISRO CS 2008 direct statement questions. Okay, the maximum number of edges in a AND node undirected graph without self loops is, okay, maximum number of edges. Okay, if we have AND vertices or AND node in a undirected graph, then maximum number of edges is what, my dear friends? N minus 1 divided by 2. No need to, okay, do. Or you, they can ask you like this: in a complete graph, if we have n vertices, then the maximum number of edges how much, my dear friends? Okay, n minus 1 divided by 2. You can check it like this: A, B, C, D, like this. Okay, we need to make what, complete graph like this. Okay, like this. So here how many edges, how many vertices node in this graph? We have 4. Okay, so how many edges we have here? 1. This is E1, this is E2, this is E3, this is what, E4, this is E5, and this is what? This is what, E6. So 6 edges we have. Okay, this is undirected graph. So check with this formula: n 4, n minus 1 into 3. Okay, divide by 2. 2 2 are 4, 3 2 are 6. So how many edges we have? 6 edges we have. Okay, with this example this is clear. So option B is correct here. If in a undirected graph you have n vertices or edges, the maximum number of edges in that undirected graph is what? N minus 1 divided by 2. Directly, okay, direct statement. Okay, this is your next question. This is a theorem, my dear friends. Okay, ISRO CS 2009 में पूछा गया. I hope आपको पता होगा. A simple graph, a graph without parallel edges or loop with n vertices and k components can have at most n minus k plus 1 divided by 2. Okay, divide by 2 edges. Directly a theorem. Okay, directly a statement. Okay, if in a simple graph we have n vertices and k components, and then that graph, okay, will have at most that much of edges, n minus k plus 1 divided by 2. Okay, simple. So n edges no, n minus k no, n minus k plus 1 edges no, n minus k plus 1 divided by 2 edges. So option D is correct here. Okay, sometimes they will give you like in a simple graph we have n vertices, like they will give you some value like 4 vertices and k 2 components, then they will ask you edges. So you need to put this formula and you will get the answer. Okay, this is your next question, my dear friends. This question asked in ISRO CS 2009. A graph in which all nodes are of equal degree is known as, okay, if we have a graph in which all the nodes are of equal degree, then that graph is called regular graph. A regular graph. If we have a graph and in which if we have all the nodes of equal degree, then that graph is regular. If all the nodes don't have equal degree, then non-regular. Okay, then non-regular. Then what? Non-regular. I hope no need to tell more. So regular graph. Nodes, we need to tell the name of that graph in which all the nodes are of equal degree. So regular graph. Option C is correct here. Okay. This is our next question, my dear friends. How many edges are there in a forest with V vertices and K components? Direct again is theorem, my dear friends. So n minus K. Okay, V minus K. Here vertices what? V. So V minus K. Okay, if we have, okay, in a forest, if we have with V vertices and K components, so how many edges possible? V minus K, my dear friend. Again is theorem. So in discrete mathematics, when you will study about graph theory, you need to see the theorem directly statement. Okay, you are able to solve the question of ISRO. Next question. Sorry guys. ISRO CS2016 में पूछा गया है, a given connected graph is a Euler graph if and only if all the vertices are off. So what is the condition for the Euler graph? Okay, if you are going to check a given graph is a Euler graph or not, so you need to check the condition. Okay, if and only if all the vertices are of even degree. Okay, if in a connected graph all the vertices are of even degree, then only we can say that the given graph is a Euler graph. Directly direct definition or statement condition, so no need to check more. Option B is correct here. Okay, this is your next question, my dear friends. The number of edges in a n vertex complete graph is n vertex complete graph. Simply again n minus 1 divided by 2. No need to check more. Option A is correct here. Okay. This is your next question, my dear friends. ISRO CS2018. The number of edges in a regular graph of degree d and n vertices is again a theorem nd divided by 2. nd divided by 2. Okay. D is representing degree, n is what vertices divided by 2. That much of edges. Sometimes they will give you like this. Calculate the number of edges in a regular graph of degree like 4 and 3 vertices. Okay, then they will ask you how many number of edges, so you need to put this formula and d divided by 2. Here n is what 3, d is what 4, divided by 2, 2 to the 4, how much 6 in this case. So like this, so no need to check the more option, and d divided by 2, d is the right answer. Okay, so I hope you understand all the questions, okay, in clear manner. Okay, सो मैं आपके लिए दूसरी वीडियो भी लेकर आऊँगा डिस्क्रीट मैथमेटिक्स की. जब तक सारे क्वेश्चन मैं डिस्क्रीट मैथमेटिक्स से आपको सॉल्व नहीं करा देता, तब तक मैं नेक्स्ट सब्जेक्ट पे मूव नहीं करूँगा. एंड ग्राफ थ्योरी के लिए जैसे मैंने आपको बताया, आप सारी थ्योरम्स पढ़ लीजिए, स्टेटमेंट पढ़ लीजिए, डेफिनेशन पढ़ लीजिए, आपको क्वेश्चन मैक्सिमम वहीं से मिलेंगे माय डियर फ्रेंड्स. तो आई होप कि आपको सारी बातें जो है अच्छे से समझ में आ गई और आपने सारे क्वेश्चंस को अच्छे से समझा होगा. तो थैंक यू सो मच गाइस फॉर योर लव एंड सपोर्ट. चैनल को शेयर करिए, अपने फ्रेंड्स को बताइए और सब्सक्राइब करवाइए, जिससे कि मैं और बेहतरीन कंटेंट आपके लिए लेकर आता रहूँ. थैंक यू सो मच माय डियर फ्रेंड्स.